and we studied about the equilibrium also. Static equilibrium means though conditions should be satisfied, net force should be 0. That means upward force equal to downward force, side force equal to this side force, and net torque is also 0. If these both conditions are satisfied, then we can say it is in static equilibrium. And static equilibrium का specialty क्या है? आपको clockwise torque is always equal to anti-clockwise torque. Okay, and उसमें आपको choose करना पड़ेगा torque about any point is 0. Static equilibrium में torque about any point is 0. But आपको एक समझ में आने का, whenever force is passing through axis of rotation, the torque is 0. That's why आपको choose करो wherever the force is 0, we can take about the torque and solve as per complete question. We should solve as per the this one. Total torque is 0. Okay, so anti-clockwise torque is equal to clockwise torque लगा सकते हो. Okay, and torque about any point is 0. We can equate. Okay, so ऐसे कर सकते हैं. 9 क्वेश्चंस करेंगे तो 2 क्वेश्चंस बाकी है, स्टैंडर्ड क्वेश्चन बाकी है. उसके बाद विल गो फॉर द काइनेमेटिक्स, डायनामिक्स वगैरह फॉर्मूलास पूरा लिखने का. ओके, चलो. इसमें लैडर प्रॉब्लम सुना होगा ना? लैडर प्रॉब्लम बोल के आपको लैडर प्रॉब्लम सुना है? किसने सुना लैडर प्रॉब्लम आता है? नहीं. देखो, सपोज मान लो दिस इज अ वॉल, सोचो दिस इज अ लैडर. ओके, ये वॉल है, ग्राउंड, ladder is leaning on the wall. Okay, now इसमें what are the forces acting on it? Suppose A is point for B ball. What are the forces acting on it? इसके ऊपर ये दोनों contact है ना? Contact है, that's why normal action force N1 perpendicular surface and इसका N2, and both are rough surface only, rough surface. So suppose मान लो, and what is the other force? Center में it is mg force acting. Suppose मान लो the having this ladder has a tendency to slip, right? To slip मान लो. So what will be the friction force? ये वाला किस तरह act होगा? It want to slip like this, right? Friction force is acting like this. This direction. I call this as F1. So नीचे as I want to slip, right? So friction will be acting here. Tendency of motion, friction will be acting in the upward direction. I call this as F2. So these are the forces acting on this ladder. Generalize first बोलूंगा, then question दूंगा, करो solve करो. Okay. So मैं now आपको this is equilibrium. Equilibrium में ये rough surface. Okay. And this is in equilibrium. Equilibrium means आपको condition क्या है? First condition क्या है? Net force in all directions is 0. Net force is 0. Now tell me, net force is 0. X direction में what are the forces acting on it? Tell me. Only in X direction. One is friction force. One is this direction force, right? N2 force. So these two forces are acting in X direction. So this side force equal to this side force, right? X direction में. So equate always. Net force is 0. मतलब this side force equal to this side force. So N2 is equal to F1 first one, and y direction में tell me y direction में क्या क्या है? N1 plus F2 is equal to mg. N1 plus F2 is equal to mg. खत्म. This is the net force equal to 0, static equilibrium. मतलब आपको क्वेश्चन क्या था, इसमें सॉल्व करके we have to find, they will tell something to find. So you have to form the equation and then solve. Okay. Second condition क्या है static equilibrium का? Net torque about any point is 0. About any point is equal to 0. Okay. Now किधर लेगा net torque? Which point will take? Tell me. Which point you want to take?
Sir, A or B.
Very good. So always don't take center वगैरह. Okay. A or B लेने से advantage क्या है? We can calculate N1 or N2 directly. Why? Because suppose about this point I am taking the torque. I'm using the torque about this point. Now this force is passing through axis of rotation. So whenever this force is passing through axis of rotation, torque about N1 is 0. That's why hinges में, hinge type of forces में, आपको about that point only we are taking, so that hinge force can we can eliminate hinge forces. कभी भी contact में hinge forces का we are eliminating wanted,ly we are taking torque about that point only, so that we are not considering that force there. So directly when we form the equation, directly N2 आ जाएगा. So net torque about any point equal 0 करके we have to solve the question. Okay. Now एक question दूंगा आपको, solve करो in terms of numbers में. Okay. ये इसका मास है, लैडर का मास है m is equal to 10 kg. Leans against a smooth vertical wall, a smooth vertical wall है. Okay. And angle they given as 37 degrees. Here I'm putting 37 degrees. Okay. The other rest on the rough horizontal floor. Find the normal force and friction force that the floor exerts on the ladder. He's asking normal forces and friction force that the floor exerts on the ladder. So normal actually asking. N1, N2 friction force. ये smooth है, इसमें तो friction नहीं है. He told in a question में he told ये smooth है. Smooth surface में there is no friction. F2 निकाल दो. Okay, मतलब in this question में F2 is not there. Okay, now solve and tell. Question understood? Huh? Now form the equations and solve.
So the video is stuck for me. Yeah, okay.
Question doubt, huh? He's asking N1, N2 and friction force F1. Here smooth है, that's why there is no F2. So first use करो net force is 0 x direction में. So upward force equal to downward force. So x direction में क्या होगा? Tell me. N1 is equal to M. Y direction में.
So they should mention the length, no?
Which one?
Of the ladder.
Length. You can take L and L so that it will cancel.
So what
So,
Ellen? Okay.
So that it will cancel automatically. First one step क्या है? X direction का force लगाओ. X direction में, Y direction में लगाओ. X direction में what are the forces? N2 is equal to F1, right? N2 is equal to F1. And upward force. You're doing that? तो इधर F2 नहीं रहेगा ना, so N1 equal to N2. So N1 आ जाएगा. So mass is given as 10 kg into G. So it is 1000 newtons. Is N1. 10G, right? Sorry. 10G. So it is 100 newtons is answer. N1. Then I guess. Now N2 find करो and F1 find करो. So torque about any point is 0, you know, and solve. Question should have no?
Yeah, sir.
Yeah, sure.
And F equal to F1 equal to N2. Okay, etc. So इसका तो आ गया, N1 तो आ गया. Now torque about any point. इधर कौन सा point ले रहा है? A ले रहा है. Torque about A point like that. Okay. इसके about you have to apply the torque. इसके about only concentrate करो. इसके about. So ये वाला तो नहीं है आपके पास. Okay. Now what is the force? किस force का torque रहेगा? Turning effect रहेगा ना? What is the formula? Force into perpendicular distance. Okay. Tell me what is the perpendicular distance? R into F perpendicular or F into R perpendicular. देखो. What is the component of L? L का इस तरफ component क्या होगा? L cos 37. So what is the formula? mg into L cos 37. See, we have to know that clockwise torque is equal to anti-clockwise, right? So here clockwise torque is equal to anti-clockwise torque. So इसका force क्या होगा? इस force को इस point के about it is rotating the clockwise and anti-clockwise body को. It is rotating clockwise, right? So what is the formula? mg into L cos 37, right? Is equal to anti-clockwise में. Tell me, anti-clockwise और दूसरा क्या है? इसके इस point के about if this force is making to rotate in the anti-clockwise direction, right? Like so. So force into perpendicular distance. Tell me about this point only perpendicular distance take. Force को extend करो, into it. And perpendicular distance क्या होगा इससे? A distance है. So tell me what is the perpendicular distance? 2L cos 37, 2L sin 37. So क्या होगा? Force into perpendicular distance, right? So क्या होगा? N2 into 2L sin 37. So L cancel हो जाएगा. Now solve and find N2. And N2 is nothing but friction on. In decimal में आएगा बोलो.
Sir, 100 and 400 by 3.
Sir, 66.65.
66, yes, correct. 66.66.
Sir, 166.66.
166.66. आया? So M is 10, 100. Cos 37 is 4 by 5. N2 sin 37 3 by 5. Subscribe. You get the answer. How much you got to know?
166.6.
Yes, आया? Sure. Now एक JEE में question करो. Have you options? 2024. Oh, super. आप ही बोलने का, wrong नहीं बोलने का. mg is nothing but W. So diagram note. Heavy iron bar weight W is having its one end on the ground and other on the shoulders of the man. Same thing. Like wall के जगह में shoulders. Lateral. Iron bar मान. Iron bar है. Yes, right. Weight is W. So W. Having one end of the ground, other end is shoulders of the man. The rod makes an angle theta with the horizontal. Just theta is given. He's telling what is the weight experienced by the man. Weight experienced by the man is nothing but ये कितना weight लग रहा है मतलब indirectly he's aiming to find the normal reaction, right? एक इस तरफ ऊपर आएगा ना normal reaction.
So the W sin theta.
हाँ आंसर इट कर ले पक्का देखो 2024 का तो normal reaction I want. Weight is nothing but normal reaction, right? N1 5.
Oh, it'll be W.
So won't it be sin W sin theta?
One end one other end shoulders. The bar is like weight experience with the person.
So won't it be W sin theta?
Sir, how
The given question,
up sir, won't I
in- See, he's asking what is the weight experienced by the man. Weight man is this one, right? This is the weight of the man. This is the weight of the rod. Okay. So weight of the man, man is exerting a force on the ground. The ground also exerts a force on the man, right? So मतलब N1 अगर find करेगा then tell us right. Nothing but weight on right. Normal action. सेम लैडर के जगह में वॉल के जगह में पर्सन है सर. Now what are the forces? Because equilibrium में generally clockwise torque should be equal to anti-clockwise torque. So this is A, O, B. So any point you take, equate and solve. So you're telling W sin eta. Rishabh बाकी है तीसरा करो.
Sir, I'm getting W by 2.
Okay, देखेंगे. आपका? माना?
Yeah.
What?
So 1 second. Let me try again.
But torque about any point is equal to 0 करो. Torque about any point is equal to 0. So I'm taking about this point. Talk about any point so that that now action will be lost. I want that N1, right?
So do I have to like take the distance as L like that I have to do?
Always torque whenever you're taking, about which point you're taking, उधर से force crystal factor उतना distance लेने का perpendicular
Now
distance
say
you take.
from point B, if I take,
This distance you take
yeah,
because R into F perpendicular.
okay. So won't you get 1 second?
आपका प्रोनाउन कितना है? You're going with the W sin eta only?
Sir, W.
On W. Again you shifted to W. Okay. आप बोले तो मैं बोलूँगा आंसर. प्रोनाउन.
So I'm sticking with W cos theta.
Okay. W cos theta, W and W by 2. चला पक्का? किसका राइट है देखेंगे? पक्का? किसका राइट है? किसका राइट है? किसका राइट है? So answer is okay. देखो रूल 24 में कितना हार्ड किस में क्या है सेल में टॉर्क अबाउट दिस पॉइंट ले लो. Okay. You took LN. Okay. Now tell me clockwise torque about any point. So torque about A is equal to 0 कर रहा हूँ. That means indirectly clockwise torque is equal to anti-clockwise torque. Right? Okay. Now tell me concept of which force is making the body to move in the about this point you concentrate. About this point, this force is making the body to rotate in the clockwise, right? And this body is making the to rotate in the anti-clockwise direction, right? N1, and this is clockwise. Clockwise bolo. What is the force? W into force into perpendicular distance कितना है? L का इस तरफ component is L cos theta. आया समझ में?
Yeah, so won't you get W into L cos theta is equals to N1 into L cos theta again?
N1 into 2L cos theta, right?
So, but isn't the perpendicular distance?
Oh no. See, this is a perpendicular distance from this point. You're concentrating about this point. This point, say, if you extend, perpendicular. This is a perpendicular distance, right?
Yes, but won't that be for N1? For N1 only, that will be the perpendicular distance, right?
और N1 का कितना है? ये लेंथ कितना होगा? ये लेंथ कितना है?
Yeah, that's L cos theta. So, won't it be N1 L cos theta?
N1 L cos theta. See, you took L by 2, huh?
No, sir, I took L in the bottom, the base.
ऐसा मत ले लो. आपको रॉड के बारे में बात कर रहे हैं. This is only just we are ground है ना, ground का रेफरेंस है. आप रॉड का लेंथ क्या लिया डिटेल में? हाँ, रॉड का लेंथ ले लो. ग्राउंड का क्यों ले रहे हैं?
Sir, but if we use F net is equal to 0, we get N1 equal to W.
N1 is equal to.
So if we use
L I'm taking. Here also L I'm taking. Clear Anshuda?
Yeah.
Okay. Now tell me, इसका torque कितना? About this point you concentrate. Anti-clockwise torque है ना? So force into r perpendicular, right? Perpendicular distance is this one. So एक बोलो कितना होगा? 2l cos theta, right? 2l cos theta into n1, right? So cos theta cancel, l cancel. So n1 is equal to w. आपका रॉड का either you can take L by 2 also, but ground का मतलब लो उसका component should be there. Rod का mention करने का always. So
Sir, but can we use F net is 0?
Net force is 0 बोले तो आपको ये step में directly you are getting the weight, right? So ऊपर लेके नीचे करके क्या करेगा? W is equal to N1, right?
Yeah.
Upward force equal to downward force. Net force is 0 means this one equation आएगा. So that is same one, right? N1 is nothing but weight only. समझ आ रहा है? N1 is nothing but weight.
Yeah.
So that's why we are trying to
Sir,
find.
by F net you get N1 is equal to W, but by using torque, N1 equal to W by 2.
W by 2. So क्या है? By 2 आ रहा है बोल के you're telling, हाँ? By 2 आ रहा है बोल के you're telling, हाँ?
So, but shouldn't you get the same answer for both if you're using F net and torque?
No, ऐसा कुछ नहीं है. Net force का आपको weight का चाहिए. देखो N1 का value is W by 2, right? मतलब आपको कैसा मतलब upward force equal to downward force, right? So N1 is equal to W आया. और कुछ? And इसका clockwise torque equal to anti-clockwise torque तो N1 कितना है? N1 is nothing but W by 2. Oh, okay. So you're telling W बोल के बोल रहे हैं net force equal to 0 बोल के?
Yeah.
नहीं ऐसा कुछ नहीं, something is कुछ problem, but understand the answer is W by 2. जब तक ये understood, this one you understood, clockwise torque equal to anti-clockwise torque.
Sir, F net will be equal to
Yeah.
0.
F net equal to 0.
Sir, it will be equal to 0 now.
Oh no. Then
Sir, then what's the
net
problem?
torque is 0, right? See, static equilibrium means net force should be 0.
No, sir,
and
you're
net
saying
torque.
there's some problem, but then F net will be equal to 0.
So yeah, sir, if you use F net in y direction, you'll get N1 equal to W. But if you use torque,
No,
we'll
sir,
get
you'll get N1 is equal to N1 plus, sir, there'll be an other normal at the ground. You're not,
Yes.
that will also
See,
be W by 2.
yes, correct. प्रणव, see, आपको net force करने समय ये भी रहेगा ना. See, in torque में we are eliminating this one. So now आपको equation क्या आएगा मालूम है? Upward force is N1 plus N2 is equal to W. ऐसा आएगा. समझ आ रहा है?
Yes.
Put on
Sir.
sure. Net force is 0 means we are not any point पे नहीं है उसमें net force में नहीं, but torque में any point is 0. That's why we are taking N1 into 0. That's why we are not counting here. But net force में all should be equal to downward force. समझ आ रहा है?
Yes, sir.
मानो आना चुड़ा ये वाला.
yeah.
So net force करने समय all the forces we are taking, not about we are not taking the force eliminate नहीं कर रहे. Torque about any point is 0. That time we are eliminating this force because it is passing through acceleration. Okay, good, Trisha. Okay, understood. Next, kinematics and dynamics of motion. इसमें already ये आपको alpha ये उसका relationship क्या है, all formulas first एक बार जगह में दूंगा. You write down all the formulas first. Then some एक का some questions I will make you do. Okay, so that formulas I'll give you try to write. Write the formulas first. कुछ नहीं है इसमें. देखो we know translation में s, this is theta दिख रहा है सर, s theta and b is equal to dx by dt, right, and omega equal to d theta by dt. And ऐसा कंपैरिजन ऑफ लीनियर एंड एंगुलर में करना इजी हो जाएगा, मतलब बाय हार्ट करने की जरूरत नहीं. लीनियर में आ गया तो कन्वर्शन में इजी हो जाएगा. एंड फोर्स के लिए में टॉर्क आएगा एंड पावर फॉर्मूला इज f dot v here tau dot omega. Impulse is mv there, I omega. Like final momentum minus initial momentum is 0 moment. So impulse is mv and I omega. Moment of inertia m के जगह में I लगाए. Translation. Someone or that. Even equations of motion also we are using. Kinematics and everything are only. We are using all the equations of motion. Again Newton's का upward force to downward force वगैरह equal करके solve करने का. Okay. देखो इधर F equal to ma is आपको न्यूटन सेकंड लॉ से आया ना, we got changing momentum by time is equal to ma. देखो ये एंगुलर मोमेंटम के बाद देखो टाउ इज m के, देखो p की जगह में एंगुलर मोमेंटम आएगा dl by dt एंड इधर देखो i m के जगह में i एंड a के जगह में अल्फा, टाउ इज इक्वल टू i अल्फा. वेरी इंपॉर्टेंट इक्वेशन. सो दिस इज न्यूटन सेकंड लॉ. ये न्यूटन सेकंड लॉ है, न्यूटन सेकंड लॉ से आया ना F equal to ma बोल के, ऐसे ही न्यूटन टाउ इज इक्वल टू i अल्फा. तो आपको क्वेश्चंस इसमें करवाएंगे, इसमें क्वेश्चंस आर देयर, सो मेनी क्वेश्चंस आर देयर आपको मेंस का, इफ यू सी द थिंग, सो मेनी क्वेश्चंस आर देयर. whenever see क्वेश्चन में whenever they are saying to find acceleration normal linear में, you what you used to do, you will take the help of force at F equal ma लगा के you will do acceleration. अगर फोर्स वगैरह दिया तो इधर भी आपको टाउ फाइंड करना आता है, आई फाइंड करना आता है, angular acceleration you have to find. whenever they say the angular acceleration, keep in mind okay I will use tau is equal to I alpha. so रोटेशन में यही यूज होगा बार बार. so आपको tau equal, whenever they ask acceleration use tau equal to I alpha. I you know all किसी का rods का इसका पूरा आता है, and tau also you know how to find r into f perpendicular, ऐसा वो यूज करके सॉल्व कर सकते हैं. ओके चलो वन सम मोर आर देयर, सम मोर भी लिखो. हां देखो इक्वेशन सॉल्यूशन एंगुलर में लिखो, ये पूरा यूज करके ओनली वी द डायनेमिक्स एंड यू नो कैन दिस.
Sir,
या
sir, what are alpha and beta?
ये याद है अल्फा बीटा, हम लोग वी डन लाइक दिस एक्सेलरेशन इज अल्फा, रिटार्डेशन इज बीटा.
Okay, sir.
तो ऐसे प्रॉब्लम्स में here b max also we done in the same equation, alpha beta by alpha plus beta into t. So these all if you done the equations then you can able to solve the questions. अब एग्जाम के लिए कंपल्सरी क्वेश्चंस कर लो, जेईई में क्वेश्चंस तो आइडिया आएगा.
So you posted the questions for RBD, right?
क्या क्या?
So did you post the questions of PYQ for rotation for this chapter?
ऑल सिस्टम पर रोटेशन मोशन पूरा उसमें है, सिस्टम पार्टिकल्स एंड रोटेशनल मोशन पूरा है. इनिशियल बेटा आंसर्स आर देयर, प्रॉपर में करो समझ में आ जाएगा, वैसे ही यू कैन अंडरस्टैंड. एंड रोलिंग मोशन निकाल दो, रोलिंग वाला आप निकाल दो. So almost we have topic 3.
Sir, rolling motion is not coming, sir.
रोलिंग मोशन का क्वेश्चंस निकाल दो. इन काइनेमेटिक्स एंड डायनामिक्स में रोलिंग मोशन आल्सो विल बी देयर. रोलिंग मोशन में क्या होगा, आपको अभी तक वी आर स्टडीइंग ओनली रोटेशनल मोशन राइट. रोलिंग मोशन में आपको आगे भी जाएगा, रोटेट भी होगा, दैट इज कॉल्ड रोलिंग. एट द टाइम दोनों इक्वेशन लगाना पड़ेगा, स्ट्रेट लाइन इक्वेशंस एंड सर्कुलर का इक्वेशन लगा के नेट वी हैव टू फाइंड, दैट इज रोलिंग. वो आगे आएगा बट इधर तक पूरा करो. ये की चैप्टर थोड़ा हार्ड वर्क करो, नेक्स्ट चैप्टर से बहुत इजी है. अगेन ग्रेविटेशन से यू विल बी इन सेफ जोन. यही इसी में पीपल को डिप्रेशन हो जाएगा, नहीं आएगा, सोचेगा नहीं आईआईटी नहीं चाहिए मुझे, ऐसा लगेगा. बट ऐसा मत डिप्रेस करो. आई नो हाउ मच क्वेश्चंस आर कमिंग मेंस में, टेल मी और चैप्टर में.
Sir, 3.
हां ये क्वेश्चन आएगा, ये क्वेश्चन आएगा सिर्फ. सो उसका एक टेंशन मत लेना.
What is toppling?
हाँ सी टॉपलिंग बोले तो क्या होगा, कुछ है उसी का भी टॉप से बन सकते हैं. मतलब ऐसा देखो, ये ऐसा पार्ट है, ये अगर कितना फोर्स से ये बैलेंस रहने का, ये बॉडी शुड बैलेंस. टॉपलिंग में क्या होगा, अगर थोड़ा ज्यादा उससे ज्यादा फोर्स दिया तो ये निकल नीचे गिरेगा, दैट्स फॉर टॉपलिंग, घूमने वाला को टॉपलिंग बोलते हैं। एक वो डिजाइन कैलकुलेशंस में आपको कितना तक वो कार रोटेट कर सकती है, उससे ज्यादा टॉप, उसके ज्यादा हो जाए टॉपलिंग हो जाएगा, गिर जाएगा। सो दैट इज द थिंग, वो टॉर्क का इक्वेशन से आएगा। तो एक क्वेश्चन दो क्वेश्चन करो, समझ में आएगा। ओके
ओके सर।
हो गया, चलो चलो। न्यूटन सेकंड लॉ ऑफ रोटेशन, न्यूटन सेकंड लॉ का ये पूरा करने वाला, मतलब व्हाट इज न्यूटन सेकंड लॉ, टेल मी। टाउ इज इक्वल टू आई अल्फा, टाउ इज इक्वल टू आई अल्फा, एफ इक्वल एम में, राइट। सो रोटेशनल मोशन में आपको फॉर्मूला बैठ करने की जरूरत नहीं है, ऑलवेज डिराइव फ्रॉम द लीनियर वाला। ओके, न्यूटन सेकंड लॉ दिस वन, एफ इक्वल एम में, टाउ इक्वल आई अल्फा, खत्म, ऐसे इसको। ओके, इससे बेसिस पे क्वेश्चंस करने का। ओके, नाउ हियर यू हैव टू अंडरस्टैंड थिंकिंग। देखो न्यूमेरिकल्स करेंगे, समझ में आएगा। रेडी आप मानो?
हाँ।
अब पुल्ली का आ गया। A block of mass m is attached at the end of the small element. A block of mass small m is attached to the end of an inextensible string which is wound over a rough pulley. Very important. Rough pulley of mass m. Pulley का mass दिया है। Of radius r. Assume that string does not slide over the pulley. ये sentences क्यों दे रहे हैं वो सब अब समझ में आएगा। String does not slide on pulley. Find the acceleration of the block when released. मैं पकड़ के रखा, when I released, इसका acceleration कितना है? But here before that I have to know these sentences. What is the difference पुराने वाला न्यूटन लॉ में पुल्ली एंड मास का, इसमें क्या फर्क है? What difference is it? पुराने में न्यूटन लॉ ऑफ मोशन में पुल्ली मास यूज्ड, हियर इसमें क्या डिफरेंस है? चल में मानो।
So 1 second. So what would be mg by m plus I by r square?
mg by alpha plus I by r square वो सब नहीं है, but I want what is the difference I want between the old Newton laws of motion में पुल्ली एंड मास, इसमें क्या फर्क?
So here there's only one block, sir. Then generally in other there's two blocks.
ऐसा नहीं है उसमें। नहीं देखो, ये रफ पुली है एंड मास है, पुली का मास भी दिया है, पुली का मास है। सो दैट्स व्हाई व्हाट विल हैपन, यू नो, स्ट्रिंग डज नॉट स्लाइड ओवर पुली, वेरी इंपॉर्टेंट। दैट मींस, मतलब मीनिंग क्या है, ये स्ट्रिंग डज नॉट स्लाइड ऑन पुली मींस ये जब स्ट्रिंग नीचे आ रहे, द पुली आल्सो विल रोटेट उसके साथ, मतलब एक्सेलरेशन ऑफ द टेंशन स्ट्रिंग का दैट इज एग्जैक्टली इक्वल टू द एक्सेलरेशन ऑफ द पुली। दैट इज द डिफरेंस। आपको पुराने टाइम में क्या था मालूम है, द स्ट्रिंग स्लिप्स ओवर द पुली, मतलब ये फिक्स्ड है, ये रोटेशन करने वाला नहीं है, वो वाला जैसे ऐसा स्लिप होगा स्ट्रिंग आएगा। बट इसमें क्या है, स्ट्रिंग के साथ पुली भी रोटेट होगा, वो याद रखो, पुली रोटेट होगा। पुराने टाइम में पुली वाला रोटेशन नहीं है, वो मासलेस है। एंड दूसरा डिफरेंस है, whenever rough pulley में whenever you put like this and like this, here tension T1 लगाए तो इसमें टेंशन T2 नहीं लगाएगा, T1 नहीं लगाने का। when the rough surface mass pulley है तो इसमें टेंशन T2 लगाने, टेंशन will be different। आपको वो डिफरेंस है। सो समझो, पुराने टाइम में पुल्ली आप वो रोटेशन करने के लिए, टेल मी, रोटेशन करने के लिए फ्रिक्शन शुड बी देयर और नॉट? फ्रिक्शन शुड बी देयर। उसमें पुराने टाइम में फ्रिक्शन नहीं है, असल इसको रोटेशन के बाद कौन करेगा? देन आपको स्मूथ सरफेस, दोनों स्मूथ सरफेस है तो कौन करेगा? नहीं होगा। सो अंडरस्टैंड, सिंस इट इज ए स्ट्रिंग डज नॉट स्लाइड ओवर द पुली, दैट मींस इनडायरेक्ट मीनिंग क्या है, दैट द स्ट्रिंग कितना एक्सेलरेशन से आएगा, सेम एक्सेलरेशन द पुली आल्सो विल हैव द सेम एक्सेलरेशन। ओके, that one you have to understand. Okay, that's उसके वजह से why we are telling that one, because ये rotational motion लगाना पड़ेगा। फिर इक्वेशन, एक इक्वेशन उधर भी आएगा। Okay, and what is the relation between normal acceleration and angular acceleration का relationship है? Tell me. Normal acceleration is a, angular acceleration is alpha. What is the relation? A equal to
Alpha r.
R alpha, बीच में R आएगा always. Okay, similarly velocity and angular velocity का V is equal to R omega. R will be coming, right? R is the radius. Okay. Now करो. Now आपको equations बनाओ and उसका solve करो.
So won't it be, oh, but this, oh, 1 minute. So won't it be, one second.
Answer आ गया. Okay. इसके ऊपर what are the force acting on it? mg tension T and is for unit इसका acceleration A, right? And इसका इस pulley का tension T है, same string another. Okay. Now apply the Newton's second law this here. What is the equation we get? Tell me. What is the equation here?
So your
mg
expression
here,
mg by m plus
So won't be mg by m plus 1 by 2 into 1.
acceleration telling, huh?
Yeah,
mg by
m plus 1 by 2m.
हाँ.
So because if you use I by r square, you have to write I as mr square by 2 and then you have to solve.
हाँ. Okay. देखो. First equation इसका लिखो. Always write the equation. So Newton second law मालूम है ना? T minus mg है, mg minus t है. So mg minus t is equal to ma. First equation. Okay. Now ये rotate हो रहा है. मतलब which force is making to rotate? Tension force, right? So torque, I can use torque का formula. Tau is equal to I alpha. One more equation आने के लिए आपको acceleration find करने का. ये rotation भी हो रहा है ना? So tau is equal to I alpha. Tau कितना होगा tell me? What is the tau value? No, perpendicular force R into F perpendicular. देखो R about this axis of rotation देखो. R into F perpendicular, right? So T into R into T, right? Is equal to what is the moment of inertia of a disc? Moment of inertia about this disc is how much? mr square, because about this axis we are seeing it. Center में क्या होगा? mr square by 2 into what is the acceleration in terms of A equal to R alpha, right?
Yeah.
And therefore A के जगह में alpha के जगह में A by R, right? Substitute A by R. Okay. Now these two equations को solve करो. A वाला equation, and we'll get the value of A. Solve करो कितना है? एक R. So T is equal to M A by 2. So substitute here. T equal to M A by 2 and get the answer.
two mg by m minus m.
Yes, correct. So mg minus ma by 2 is equal to ma. So A सब लिखो. mg is equal to A common लिया तो m plus m by 2. So क्या आएगा? A into 2m plus m by 2. So therefore A is equal to mg, right? So A is equal to 2 mg by 2m plus 2. आपको दो इक्वेशन बनाने का, then only you can, because आपको टेंशन एंड एक्सेलरेशन दोनों डिफरेंट वेरिएबल्स है ना, दो इक्वेशन रहेगा. एक रोटेशन को वैसे आ रहा है, why it is rotating I'm saying that because they do not slide over each other. That means relative motion between the pulley and the string is 0. There is no relative motion between them. So ये जाएगा, वो भी सेम इंस्टेंट में जाएगा. There is a difference. पुराने टाइम में पुली रोटेट नहीं होगा, massless है, सब that's why tension will be same, but the tension will be different. And ये rotate हो रहा है. Why we are rotating here? So that we can use this equation. Okay. चलो ready है? Anshuda? तो कर on the video and do. So find the acceleration of m1 and m2 in the Atwood machine if there is a friction present between the surface and the pulley and thread does not slip over surface of the pulley. Moment of inertia is I only. So no need of converting again. Moment of inertia directly I दे दिया. So answer will be I terms में आएगा. He's asking find the acceleration of both the thing. So इधर क्या होगा? Downwards is m1g ऊपर t1 So इसमें क्या होगा? T2 है because rough pulley है and downwards is M2G and acceleration ऊपर. In mass M1 is greater than M2 ऊपर ऐसे
Sir,
नीचे आ.
Is it M1 minus M2G by M1 plus M2 plus I square by R?
हाँ भाई
I by-
I square है
I by
So
R.
it'll be I by R square.
भाई फार्मूला ना.
So yeah, so it's M2 minus M1 into G divided by M1 plus M2
Plus
plus I by R square.
yes correct. But method से करो. I want method from method से. Don't use
For
formula.
exam, direct formula for use will be easier. No?
See, okay, but problem क्या है? आपको मेथड समझ में नहीं आया तो अगेन दूसरे पर कॉम्प्लिकेटेड क्वेश्चंस में प्रॉब्लम हो जाएगा. एंड दैट टू यू नो सेकंड ईयर के बाद अगेन फर्स्ट ईयर का ये सब पूरा भूल जाएगा. विल टेल सम फॉर्मुलास आर देयर, सर दिस फॉर्मुलास आर देयर, सर बोल के बोलेगा. सो ऑलवेज मेजरली कांसेप्ट्स लेस फॉर्मुलास सो दैट आपको यू कैन सॉल्व एनी क्वेश्चंस. ऐसा ट्राई करो. मतलब you also know formula, Spisha? You know the formula? हाँ, then मेथड से करो. So first equation, second equation बनाओ and third equation बनाओ. So first equation क्या है? इसका acceleration downwards है ना? So m1g minus t1 is equal to m1a. First equation. Second equation, since acceleration ऊपर, so t2 minus m2g is equal to m2a. And since ये रफ है, ये स्लिप नहीं हो रहे, रोटेशन हो रहे हैं, so ये अल्फा से रोटेट होगा ना, so angular acceleration will be there. So क्या होगा? Tau is equal to I alpha. Okay. So net torque will be net torque. We are fine because torque किसके वजह से रहेगा? Tell me. इधर ये पुल्ली किस वजह से net torque will be? Tell me. कितना होगा? इसका radius is R. Tell me. Net torque will be yeah. Tell me. R into F perpendicular and this also R into F perpendicular. So which direction the acceleration is going? Tell me. Which direction acceleration is going? It is going downwards, right? So this direction will take as positive. This direction will take as negative. So net force will be how much? Tell me. Net torque will be R into T1 minus R into T2. ये समझ में आया? Net torque will be आपको since acceleration downwards है, इस direction में you are taking positive, this direction में should take as negative. So net torque is equal to I is I only. Alpha is A by R. Now solve. So T1 R common लेके T1 minus T2 is equal to I A by R square. R को नीचे आया तो I A by R square. Okay, now solve. First equation, second equation, this is third equation. Find acceleration. A चाहिए. Just subtract, right? T1 minus T2 चाहिए ना? So subtract 2 minus 1. 2 minus 1. So that आपको T1 minus T2 value आएगा. तो कितना होगा? If we subtract 2 minus 1. T2 plus T1 आएगा ना? So subtract 1 minus 2. 1 minus 2 करो. So minus T1 minus T2 plus M1G minus plus M2G is equal to M1A minus M2, right? And separating 1 minus 2. Now from this T1 or T1 T2 को जब substitute करो, anything you can do. Solve करो, 3 equations solve करो. On the video and solve them by method से करो. Or if you see the T1, T2, add the equations, all 3 equations add करो, all 3 equations add करो. कितना होगा टोटल? See, minus T1 plus T1 cancel, minus plus T2 minus T2 cancel. So T का निकल गया. Add all the equations. What will you get? M1G minus M2G is equal to और क्या चाहिए? M1A plus M2A plus IA by R square, right? इधर A कॉमन ले रहा हूँ. M1 plus M2 plus I by R square. M1 minus M2 into G. So therefore, A is equal to M1 minus M2 into G by M1 plus M2 plus I by R square. तो मेथड से करो, विल गेट द आंसर. बट पिछले क्वेश्चंस दिया तभी हम लोग सोचेंगे शॉर्टकट तो बहुत मुश्किल हो जाएगा आगे का. ठीक है, लर्न किया तो अच्छे होंगे, डायरेक्ट क्वेश्चन का आंसर. बट थोड़ा पिछले क्वेश्चन दिया तो आपको मेथड ही हेल्पफुल. पर अरे व्हाई दिस पुली इज रोटेटिंग हियर बिकॉज ऑफ द इट डज नॉट स्लिप बोल के बोला, दैट्स व्हाई इट्स रोटेटिंग. उसके वजह से ओनली वी आर यूजिंग द इक्वेशन हियर. हां
Sir, if both the masses are at different distance from the pulley, then how do you do?
बोथ मासेस आर डिफरेंट डिस्टेंस. मतलब
So like the
Different
radiuses are
distances.
different.
सी पुली का रेडियस तो सेम है ना.
Yeah,
R will be same or not?
yeah.
Forces will be different, right? Forces will be different only. T2 into R, T1 into R.
So no, so suppose for T1 it's 2R and for T2 it's something else, 3R or something.
उसका करो. You should take as 2R into T2 and here 3R into T1. R में R get cancel हो जाएगा, right? इसमें.
Okay.
तो मेरा.
Yes.
ऐसा. Next. Answer done, Krisha? I know. Yes. Check. ना करो. आप ही करो. Same thing, right? If the figure M1 without friction, without friction, on a horizontal surface, the frictionless pulley is in the form of cylinder of mass M and radius R. So इसका mass M है, capital M, and radius R. And string turns the pulley without slipping. Without slipping, the string is turning. And find the acceleration of each mass and tension of each part of the string. He asking acceleration and tension of the string. So इसका मान लो M2 is greater than M1 मान लो. So इसका acceleration ये, इसका भी acceleration. Now use the equations. The pulley is rotating. Use the three equations and solve. Use the method and solve. Let me follow. M2G. This is you can take as T2, T2. This is T1. That's all. Three equations आएगा and tau is equal to I alpha लगा के final answer acceleration बोलो.
So for the torque equation,
हाँ.
it'll be T2 minus T1 or T1 minus T2.
Acceleration किस तरफ जा रहे हैं? नीचे जा रहे हैं ना? So this direction is taken as positive. So T2 into R minus T1 into R.
Okay.
Sir,
Sir, the T1 will be M1A, right? I got T1 equal to M1A and M2G minus T2 equal to M2A.
Yes, M2A. And T2 minus T1 times of R is equal to I alpha. I is I only.
M2G by M1 plus M2 minus capital M by 2.
No, last one wrong. M2G by M1 plus M2 plus moment of inertia I only put, right?
Sir, no,
So,
sir, I
but
took for
shouldn't
this.
I of
Sir,
ठीक
they
है.
mentioned it's a.
Yeah. In terms of I में बोलो. I में बोलो.
Sir, 1 second.
Sir, m2 minus m1g by m1 plus m2 plus I by r square.
नो रॉन्ग, फॉर्मूला यूज करेगा तो ऐसे आएगा, फॉर्मूला यूज करो, मेथड करो.
So m2g by m1 plus m2 minus I by r.
थोड़ा रॉन्ग है. फर्स्ट ऑफ ऑल माइनस नहीं आएगा उधर, एंड आर स्क्वायर आएगा.
So t1 will be positive and t2 will be negative, no?
इन दिस डायग्राम में T2 is positive, right? I look here.
Okay, okay, okay.
And R square आएगा. मानो कितना तक आएगा?
Sir, it will be plus, sir.
हाँ प्लस only. So I by R square आएगा.
Yes, sir.
Yes.
Sir, won't the I be half? I mean, I will be half mr square by 2 only, right?
See, but options में आपको I में दिया है, in terms of I में दिया है. So I don't.
I already
हाँ.
I already converted though.
हाँ ठीक है, बोलो आंसर बोलो.
1 second. So I got acceleration as m2g by m1 plus m2 plus half m.
Correct. So यार है.
So but won't it be m2 minus m1?
असल M2 minus M1 कैसा आएगा? Tell me. You're applying formula.
So no, I did it.
What is the equation? First equation, tell me.
So m2g minus t2 is equal to m2a.
M2A. And this one?
And
T1
t1 minus m1g is equal to m1a.
M1G किधर से आ रहा है? Descent force देखो, descent force any force is no, right? So T1 is equal to M1A.
Oh shit.
Ah. Okay, from that you will get the answer as M2G by M1 plus M2 plus I by R. Okay, now J is special. Maybe options. It is 2017.
Sir, 3g by 12 sine theta.
Without calculating something, अंदर मत बोलो यार. Calculate nicely. Why? Found out कुछ या?
No, sir, I saw a question which are the same options.
नहीं आंसर. Wrong answer. Calculate करो. इधर से करो. It is pivoted at this point. ये इधर से release किया. So you asking there is negligible friction in the pivot. The free end is held vertically above the pivot and then released. The angular acceleration of the rod when it makes angle theta with the vertical. When it is falling from here, at this point, what is the angular acceleration? Alpha is how much? It's at an angle theta. Okay. कुछ नहीं आपको. Simply, you tell me why it is falling down, because of which force it is falling down. Tell me. Which force is making to rotate in a clockwise direction?
Mg.
Mg. So here Mg. So Mg. Okay. This angle कितना होगा? Tell me. This angle कितना है? ये angle कितना है? Rod
Theta.
and vertical. Rod and vertical is theta. Is wrong theta. So tell me what is the component here? Mg cos theta
Yeah.
and Mg sin theta. Right? Now apply the, whenever they ask acceleration, what I told, whenever question में they ask acceleration, always use Newton's second law. कौन सा? Tau is equal to I alpha. Now find alpha find करो. I मालूम है ना about this pivoted point? Rod का end में ml
Yeah,
square
ml
by
square
3.
by 3.
हाँ करो. Use करो ना. That'll answer. And total length is L, right? So this length will be L by 2.
Yeah, sir. 3g by 12 sin theta.
Oh, yes, correct. This answer. Force into perpendicular distance. So at this point, man, about this point I'm saying, right? About this point. So that a hinge force is not, we are not calculating yet, right? So क्या होगा? Force into this is and R into F perpendicular. R is from here to the wherever the force is applied, the distance go. L by 2 into mg sin theta. And here m r ml square by 3 into alpha. M cancel. Take L cancel. So alpha is equal to 3g by 2L sin. Anshuda, tau is equal to I alpha लगा that's it. Anshuda, hello. करेगा? ये option. Numerical based वाला. So this no options. A uniform disc of mass 4 kg and radius 10 centimeters is mounted on a fixed horizontal axle. इसमें mount कर दिया a disc है. And shown here a block of mass 2 kg hangs on a massless cord wrapped around the rim of a disc. This is massless cord. During the fall of the block, the cord does not slip. Okay, that means AV rotated over. We can use the torque equation also. There is no friction at the axle. At this axle, there is no friction again. The tension in the cord is tension in the cord. Just tension in the cord. Disc है about this point.
Sir, I of disc is mr square by 2, right?
MR square by 2. नंबर आएगा कल आंसर देखेंगे 2022 मेंस
So do you get fraction?
No, perfect number. Again, you use M2G minus M1G, नहीं है? Method से करते हैं.
So can you give options or is it a numerical only?
Numerical based actually. 2-digit number.
Sir, for this question, in the previous to previous question when there's only one block hanging, the acceleration was mg by m plus 1 by 2m, right?
Sir, I
So
got 30.
can't we just directly use that here?
No. So what's the use of
Sir, will it be mg minus t or t minus mg?
acceleration distance is heading to is coming downwards, right?
Yeah. So I got 10.
Taking
Sir, I use the acceleration, the mg by m plus 1 by 2m, and then I got acceleration as 5, and then I can write torque as half into 1 second. Oh, half into, wait, 1 second, 1 second.
Sir, I'm getting 10.
perfect answer. Correct answer.
So 1 second. Sir, I found acceleration as 5. And then is there a direct formula for torque and acceleration?
आप formula में गया काम से. I'm telling you. Formula से temporal purpose not देखो. Go for a concept actually.
Wait, sir. If I use mg minus t is equals to ma, I'll get
first equation. Now second equation क्या है? इसका radius आ रहा है ना? So tau is equal to I alpha use करो. Tau is what? T r into f perpendicular, right? R into f perpendicular is t. That only we have to pay attention, right? I is mr square.
m square by 2.
And this is a by r.
A by r, yeah.
And first equation.
We'll get t as half ma.
mg minus t is
So
equal
we'll get
to.
t as half ma, right?
Answer कितना बोलो?
10 only. If you use, yeah, if you get t as half ma, yeah, 10, yeah.
Always go for a method. If you go for a formula, अभी method दूसरा फंस जाएगा. They can use multiple blocks also. That time आपको प्रॉब्लम हो जाएगा. अंडरस्टैंड करो. आपको जेईई मेंस का डायरेक्ट फार्मूला नीट नहीं है. नीट का डायरेक्ट फार्मूला ओनली. ये जेईई मेंस का आपको इतना इजी नहीं रहेगा. ओके, सो प्रॉपर वे में कॉन्सेप्ट वाइज का करो. Easy. Okay, sir. Theta in terms of time is given. He's telling that torque on the wheel becomes 0 at what seconds?
So we have to double differentiate it to find alpha, right?
Oh, whatever answer.
So what do I take?
Sir,
I
1
as?
second.
So what is I be? What will I be?
No, sir, answer is 1 second.
Sir, what will I be? Should I take I as mr square by 2?
I don't know. You see the question answer. Tau will be become 0 when at what seconds? Tau is 0.
So I got 2 seconds.
Okay. So options will give 2 seconds.
Oh no, one. Sorry, one. I got one.
Yeah, one is the answer.
Yeah, 1. Okay, got it.
Yeah, one. Aya?
So just double differentiate it.
And tau is alpha, right? I तो निकल गया.
Yeah, I can't be 0, so that should only be 0. Yeah.
See, whenever you are using this one, tau is equal to I alpha. Suppose if they're talking about average torque, alpha will be the average alpha you take, right? And you know how to find average alpha. See, these are the kinematic dynamics. बोलते हो ये कुछ नहीं ये same equations of motion, the rotational motion we are doing that shit. Okay.
So you have to use the formula IA by R, right? And then you can find acceleration based on the first formula.
See, what is still different? The magnitude of average torque. Class. Tau is equal to I alpha and alpha average you have to use. Tau average push that's why alpha average you have to. Okay. So I moment of inertia they given up.
Yeah, 3.
Given, right? Class. Alpha average find and what is the average
This
acceleration?
is the first law, right?
नहीं, what is the normal acceleration का formula? Average acceleration का formula क्या होगा? Normal linear में change in velocity by time, right?
V minus U by T.
V minus U by T is the average velocity. So alpha average will be omega 2
So I'm getting 3.
omega 2
Sir, I have a doubt.
minus
So
omega 1 by
first you
T.
have to convert the 54 kilometers per hour into meter per second, right?
Meter per second convert करना पड़ेगा.
And then you have to use the omega is equals to V by R.
Because we know how to convert linear to angular. V equal to R omega, right? Omega equal to P by R. खत्म use करो.
So the final omega is 0, right?
Final is 0.
So then won't you get alpha and negatives?
Negative no problem. Minus लगाओ.
Okay, 1 second then. So then wait.
Sir, 6.6.
Oh, I alpha, yeah, 6.66.
Yes, perfect. So आपको कन्वर्शन आने का इधर फंसने का नहीं है. कन्वर्ट अल्फा पूछ रहा. अल्फा इज नथिंग बट नॉर्मल एंगुलर एक्सेलरेशन. चेंज इन वेलोसिटी बाय टाइम. एंगुलर वेलोसिटी बाय टाइम. खत्म. So always compare linear and angular में try to convert. So कुछ नहीं. Then the portion will be easy that time. Okay. आ गया प्रणव?
Yes, sir.
रोटेशनल काइनेटिक करेंगे और किसका काम है? Work is there?
Sir, what I don't know if we have this for exam though.
Huh?
Sir, I don't know if we have this for exam.
Oh, this all comes under kinematics only, kinematics and dynamics only. The only tau is equal to I alpha only. Kinetic energy का फॉर्मूला क्या है नॉर्मली लीनियर मोशन में?
Half mv square.
हमारे इसका एंगुलर में क्या होगा?
Half I
I omega square.
ये नहीं है, क्वेश्चन में नहीं है. Question not there, sir. Question. This all comes under rotational. ठीक है, no problem. आप पढ़ो, आप नेक्स्ट क्लास में करेंगे सब कुछ.